Hello, today we're going to continue our work in algebra and we're going to look at solving quadratic equations. And we're going to start off by doing the same question two different ways, one by factorizing and the other one by using the minus b formula, which is in your log tables. And then we're going to have a chat about how these questions relate to graphs of functions and what it is physically we're doing when we solve them. But we're going to go through the algebra first, make sure everyone is happy with that. So I have 2x squared plus x minus 25 is equal to minus 10. I recognize that I have a quadratic, so my first job is instantly going to be get everything over to one side equals 0. This is the structure of this type of question. Plus 10 on both sides, and I get 2x squared plus x minus 15 is equal to 0. That's always going to be what we want to do first. If we can get rid of any fractions, we get rid of any fractions, we get everything over to the left-hand side. And if we're doing the factorizing method, it's generally nicer to have a positive number in front of the x squared. So if it's negative, we would multiply both sides by minus 1. But now we've got this in the position we like, we're going to factorize. And so to factorize our numbers, we are going to take the number in front of the x squared and the number on the end and multiply the two together. And we're going to get minus 30. Then I'm going to write out all of the factor pairs, all the numbers that multiply together to give minus 30. So I'd have 1 by minus 30, 2 by minus 15. Notice what I'm doing here. I'm starting out with 1, 2, then 3, then 4, then 5, then 6. This is how I avoid missing a number in my list. Because if I'm under pressure in an exam, the chances of me missing a number if I try to do this too much in my head are very high. So this structure of starting out with 1 by something, 2 by something, 3 by something, 4 didn't work, 5 by minus 6. And I suspect that my next one will be 6 by 5, so I stop writing out factor pairs. Or I could get the negative version of that. I could have minus 1 by 30. Or I could have minus 1 by 30. Or minus 2 by 15. Or minus 3 by 10. Or minus 5 by 6. So I've now listed all of the numbers that could multiply together to give minus 30, whole numbers. And then I'm looking for the pair that is going to also add together to give plus 1. Remember, or if there's just a letter sitting there, it means there's a secret plus 1 sitting in front of my x. So I'm looking for which pair is going to add together. And I have minus 5 by plus 6. Minus 5x plus 6x would give me 1x. So this is the pair that is going to work for me. So then, if I break this plus 1x into minus 5x plus 6x, minus 15, a reminder, this is exactly the same thing as I started with, because if I added these numbers back together, I would get back to where I started. I haven't added anything to this equation. I haven't changed it in any fundamental way. I've rewritten the way that it looks because it helps me with factorizing. But there is nothing fundamentally different here than there was in my previous line. Now I have 4 terms. And I know that in algebra, if I have 4 terms together, I'm probably going to factorize the first 2 and then factorize the second 2. So I have x on 2x minus 5 plus 3 on 2x minus 5 is equal to 0. I now have a common factor of my 2 brackets here. If I found that the signs were wrong here, if this had ended up being minus 2x plus 5, I would have taken out a factor of minus 3 in order to get the signs the same in both brackets. That isn't needed here, but it often comes up. So then I end up with 2x minus 5 on x plus 3 is equal to 0. Now why is this useful to me? Because if I had this bracket summing to 0, I'd have 0 multiplied by some number would be 0. Or if I had this bracket summing to 0, if x was minus 3, I'd have minus 3 plus 3 would be 0. I'd have 0 multiplied by some number over here. It would be minus 11. And I would end up with minus 11 by 0 would be 0. So if either of those brackets are 0, I will end up with the equation 0 equals 0. So both solutions are valid. So I must take both as a possibility. This is the argument for why we bother to factorize when we are trying to solve our quadratics. Because if we can get one number multiplied by the other is equal to 0, then either this number is 0 or this number is 0, which is what we've done here. Then we're just rearranging equations in order to get x by itself. We're solving these simple linear equations. We end up with 2x is equal to 5. Divide both sides by 2 to get x by itself, which is what we always do in solving equations. We get x is equal to 5 over 2. I find it easier for graphing to rewrite that as a decimal. So if you're trying to draw sketches, decimals will help you. Mixed numbers would also help you if you prefer to write in mixed numbers rather than decimals. Either will be perfectly acceptable, so long as you're following the guidelines that they give you in the question in the exam. But for sketching, decimals are usually the easiest thing to do. 5 over 2 is hard to picture, but we all know what 2.5 will look like on our number line. So those are the roots of our equation. So these are our roots of our equation. Our x is equal to 2.5 and x is equal to minus 3. This is our language that we use for these situations. They're the roots of the equation, and if we look at our picture of our equation, they're where we cross the x-axis. Now what does that mean for y values? It means where is our y value equal to 0. And if we come back up to the top here, we would have y is equal to our quadratic. So we are looking for where y, what values of x will make y equal to 0. Y is going to be 0 all along the x-axis because our y numbers are going minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. So it's 0 for the y's along the x-axis. This is a very important concept to have totally solid in our minds. Likewise, if we're looking for where our line is going to cross the y-axis, the x values must be equal to 0. And this tells me where my line is going to, we say, intercept or cross the y-axis, because I set anything with x in it equal to 0, because all of my x values are going to be 0 along the y-axis, and I'm left with y must be equal to minus 15, the constant on the end. So this tells us a lot about our quadratic equations. We can look for the constant on the end is going to tell us where we cross the y-axis, because anything that has an x in it, when we cross the y-axis, it must be 0. So we're just left with a constant. And for our roots, where we're crossing the x-axis, we are setting y equal to 0, because that's what happens on the x-axis. Now, that's a link then between our sketches, which are extremely important tools to have, and our factorizing. Now, sometimes we will come across quadratics that we just can't factorize in this way. They don't have nice whole number brackets that we can break things up into. So what I'm going to do is use the exact same equation that I've sketched here, that we've talked about here, and use the minus b formula on it. And the minus b formula is in your log tables. And what we are going to do is write down the different bits we need to sub in. And we are going to write down our minus b formula. It is extremely important that we write this down from the log tables so that we don't make any mistakes. And if we make a substitution error, but we have written this in, the examiner is much more entitled to give us marks. If we just sub something into our calculator and write down a wrong answer, we're getting 0 marks. If we show every step in our going down and it's obvious we just made a substitution error, that gets listed as a slip, which means that you lose almost no marks even though you get the wrong answer. So it is extremely important that we are writing down the value of A, B, and C, writing down the formula that we are going to use, and then subbing into our formula. This guarantees us big blocks of marks. So if I sub into that, then everything I sub in is going to go inside brackets without exception. This is particularly important because these questions will heavily rely upon you putting stuff in brackets. Into the calculator, I should say. So the brackets are particularly important because we are going to be subbing this stuff into our calculator, writing this stuff into our calculator, and calculators rely heavily on brackets for when things get complicated. If we skip our brackets work, life becomes very difficult. So we end up, when we put things into our calculator, put the square root part into your calculator separately. And in this case, you will get 11. So the square root bit goes into your calculator. There's a plus or minus here, which we can't deal with in the calculator. So we put the square root part into our calculator separately. Sorry, that should be plus. And once we've tidied it up to this degree here, we are going to take the positive situation. So this means plus or minus. So I'm going to take where it's plus, and then I'm going to take an x value where it is minus. And when I simplify that down, I get x is equal to 5 over 2. And x is equal to minus 3. And those, again, are my roots. So what does my minus b formula give me? It gives me the roots of the equation, which is where my blue line, my function line, is crossing the x-axis. Put another way, it's where y is equal to 0. So that is the general principle that we have here. And just to remind you of another bit of English, our two brackets here, so this bracket here and this bracket here, are the factors of our quadratic. The minus b formula, we already know from our previous work in algebra, can be used to find the factors by rearranging this into the form where everything is equal to 0. So if we rearrange those equations to get equals 0, then we would have the factor. So this would be the factor and this would be the factor. You can see that these are the same. So that is our roots and our factors for our quadratic. And we've also looked at how the graphs of these equations work, how the sketches of these equations work. And the last thing I'm going to very briefly touch on is if we were asked for something like where this is equal to, we'll say minus 5. If we were asked to use our sketches to figure out what the value of this function is equal to minus 5 would be, we would go y is equal to minus 5. We'd go across to our graphs and down. We would go across to our graphs and down. And I would say that roughly speaking, our values of x would be 2 and x would be equal to minus about 2.5. And we'll look again at how to do that algebraically. You would just take the situation like we did with our top example here, get everything equal to 0 and solve the new quadratic. That's how we do it algebraically. If we're asked to do it graphically, that's how we would do it. And that's what we need for basic quadratics.